We are going to look at the diagram we have here on the board. It is known as velocity time graph. Velocity time graph. So here, if you look at the vertical, we call it the y-axis here. You see that we have what? Velocity in meters per second. Then you come to the x-axis, that's the horizontal axis. We have what? The time, which is measured in what? In second. Now look at here. The diagram gives the information of a car. It says that the car starts from rest, accelerates uniformly, and attain a speed of 80 meters per second in 30 seconds. It means that it takes the car 30 seconds to attain this speed, the speed of 80 meters per second. The car then maintain that speed, that steady speed in the next 30 minutes. Look at here, from the point that the car attained this velocity, or you call it speed of 80 meters per second, is 30. It takes the car another 30 seconds to maintain that steady speed. Now you look at here is the word we have here, a steady speed. Now at that point, the car now decide to do what? To return to rest. Now the car now start to do what? To slow down. Look at here, it now start to slow down. It takes it 40 seconds to come back to what? To return to rest. So here you are asked to do what? To find the acceleration of the car, or during the first stage of the journey, which is this line that is going up here. And also you are asked to do what? To find the deceleration of the car during the last stage of the journey, and the total time it takes the car to return to rest. So it's very simple. Let's look up here. Here I told you that acceleration is equal to change in velocity all over time. Change in velocity all over time. Now, since you know that the car starts from rest, and it takes the car what? 30 seconds. That means the time t here is equal to what? 30 seconds. It takes the car 30 seconds to do what? To attain this 80 meters per second. Since the car starts from rest, that means that the initial velocity is what? 0. So the 80 here is what? The final velocity. So we now write here change in velocity all over time. This is equal to what? Is equal to v minus u all over what? See, and that is equal to v here is 80 minus 0 all over what? It takes the car what? 30 seconds to attain that speed. That is 30. You can write 30 minus 0. You can as well write 30. So here let me write 30 minus what? 0, and that is equal to 80 all over what? 30. This cancel this, you are left with what? 8 all over 3. You divide 8 by 3, you have 2, and I think that is equal to 2.67, and the unit of acceleration is what? Meters per second square. Now we are talking of deceleration, the time it takes the car to return to rest. Since the car attains the maximum velocity here and maintain that same velocity for the next 30 seconds, and the car now decide to return to rest, the time it takes the car to come back to rest is what? Is 40 seconds. Yes. So here we are talking about what? Retardation. Retardation is what? Is negative acceleration. So we now write that retardation, you see that you call it retardation, you call it what? Deceleration is equal to, we now check here, you come here and see, now look at where the car started to come to do what? To come to rest. Now you now say here is t80. Now write the 80 minus 0 here, which is the initial velocity, 0, all over 100 minus 60, because this is it was at this point that the car started coming to rest, minus 60, and that is equal to 80 all over 40, and that is equal to 2 meters per second. Then the total time it takes the car for the journey is equal to total time. You write that right, total time. From the graph here, you've seen that the total time is 100. But now look at it now. The first stage of the journey, it takes the car 30 seconds, you write 30 seconds, plus the second stage, which is the time the car maintain that constant velocity, is also 30. From 30 to 60 here is 30. Then the time it takes the car to do what? To return to rest is from here to here is 40 plus 40, that is equal to 100 seconds. So it takes the total time the car used for the journey is what? 100 seconds. Thank you.